Coastal Change Through Historic Trend Analysis by Gary Momber, Julie Satchell and Jan Gillespie. Within this presentation, I will outline the need to understand long-term coastal change, the historical data we can use to inform our understanding of coastal change, and I'll present an assessment and validation of some of the data sets. We need to understand long-term coastal change because the current coastline is the foundation upon which future developments take place. The coastline has evolved over many thousands of years. The coastline continues to evolve. We've seen that interfering with or disrupting the long-term natural processes can result in unintended consequences. So understanding the patterns of coastal evolution can inform management decisions, and the historical narrative can aid dissemination. I will begin by looking at the Western Solent. This is a case study within the SARC project. I'm using it because it was an area that's undergone a lot of changes in the last 8,000 to 9,000 years due to sea level rise. Initially it was an estuary that opened up to the east, but about 2,500 to 3,000 years ago the Needles Channel formed. And this meant that an open seaway ran through the Western Solent that started to erode away all the sediments that were laid in the previous 7,000 to 8,000 years. The areas I'll be looking at will be stretching from Cadland Causeway in the Northwest Solent past Thorns Bay to Hurst Spit and also Boldner Cliff. In embayments and in sheltered areas here behind Hurst Spit, many of those estuarine sediment deposits remain. We can see here at low water large areas of mudflats. These stretch out for a kilometre in some places, and underwater you can actually find the remnants of the alluvial sediments that built up over several thousand years, although these tend to be truncated in the offshore zone where they face the central channel. However, if we look further up the Solent to the east, between Calshot and Thorns Bay, we can see a lot of the mudflats have now eroded away. But this is quite a recent phenomena, because we can see just in the chart regression analysis that over the last couple of hundred years the mudflats have receded about sort of 300, 400, 500 metres. This could be down to sea level rise, but sea level has been rising for a long period of time, and it's more likely to be because of the depletion of sediments into the Solent and because of the hard defences being put up, as you can see on the right hand side of this image here, the hard defences that have increased the backwash of the energy, therefore eroding away some of the mudflats. When we get down to ground level, we can see that the surface sediments have gone and we're down to the geology. But within that geology, we're getting a number of archaeological features. This particular one is 1500 BC. It's a Bronze Age structure that's recently been exposed. If it had been exposed for longer, it would be eroded away. So one thing it shows that this area has recently been devoid of sediments for the first time in a few thousand years. We can also see that this particular structure wouldn't survive if it was in open water, so at the time it must have been surrounded by those mudflats we talked about earlier. Further evidence for the formation of the Solent can be seen at its west end at Hurst Spit. Here the feature has to be recharged every year to stop it from breaching and to protect the monuments at the end. There's a Henrican castle and an extension that was built in the 1880s. The castle was built at a very strategic location, but it didn't take into account the long-term coastal processes, and as a consequence, this last February, part of it has collapsed into the sea. The loss of the castle highlights an issue that's been ongoing for many, many years, and evidence for this can be found underwater. In this particular location here at Boldner Cliff, you can see part of the land surface is 8,000 years old. Like the sites up by Thorns Bay, these have only recently been exposed, and you can start seeing tree stumps, edges of cliffs, and what was down there an old boat building site as well. In fact, there's a bunch of archaeology, including that platform which you can see that's been excavated from the site and reconstructed on the bottom of the site. So all this material is just recently being exposed within the landscape for the first time in 8,000 years, which demonstrates recent erosion that needs to be understood to try and monitor the speed of loss in the Solent. Sites like this also provide tangible evidence of sea level rise in the past for the skeptics that do exist out there, and they help reinforce the need for action to be taken to defend the coastline. So the data that we need to analyse and assess to try and understand these past changes include palaeoenvironmental data, archaeological material, maps, charts and historical documents, art and photographs. In our pilot study areas, we've been looking at these different data sets in a systematic way and then getting the information and putting it on a database that can then be accessed through a maritime atlas, being a geospatial viewer. We looked at databases and heritage archives, as you can see listed on the right there, and we've also looked at studies and various publications, a main form of data being the local historic environment record. Before we put the sites onto the viewer, however, we score them. We look at sea level change, environmental change, temporal continuity, and a non-scoring criteria, which is qualitative, to give it a coastal context. Now we score them as high, medium or low in relation to their value in helping us to understand long-term change. And we flag up the high ones as the ones that coastal managers should look at to inform our understanding. Maps and charts can be another great resource, especially over the last couple of 100 years, where charting and mapping has been really accurate, so you can look at them and make direct references to change. Older maps and charts are a bit more subjective, but they are of value, and quite often they do have fixed points that we can make reference to. They're also very useful tools when disseminating to the public. To quantify the varying levels of information that you find in maps and charts, these two are scored. The scoring criteria are topographic accuracy, geometric accuracy, and chronometric accuracy. In the case of Newlyn, we looked at 13 maps and charts which are on the database, and they can all be compared. When looking at art, you also have to assess the qualitative or quantitative value. Some artists or artistic schools are very accurate, and you can use the features portrayed to measure changes along any particular part of the coastline. The criteria we use when scoring art are the accuracy of the artistic style, the most advantageous medium, the value of the subject matter, and the value of the time period. But something that can be of even more value is the ability of art to tell the story of past change. Art is something that we all appreciate and love, and as such it's been a very useful tool when trying to tell the story of past change. The same is true of historic photographs and postcards that can tell a great story, and of course they can be very accurate if they're taken from the right angle, the right place and the right time. The criteria we use for this scoring are the purpose, whether there's a coastal view, if it's a heritage view, and of course the quality of the imagery. So we can now look at some of the evidence around Newlyn to see how the bay has developed. We can look at fixed structures, like the harbour started in 1437 with more robust elements built in 1732. We can look at these through time to see how it's had an impact on the coastline, if at all. We can also look at wrecks and elements, structures left behind from wrecks, and use those as reference points to measure from those to elements of the coastline or parts of the coastline which might have changed, advanced or regressed through time. We can look at submerged forests. This gives us an idea where the coastline would have been, say, 2, 3, 4, 5,000 years ago, but it also tells us about recent changes. Because they've been exposed, it means these sites are being stripped, they're under threat. Therefore, these changes may have an ongoing impact on the future coastline. If there has been an increase in erosive forces, it would be good to find out why. So we can look at the historic photographs and postcards to see what changes have taken place in the relatively recent history. And an obvious one on the right hand side is the development of the new harbour at the end of the 19th century. We have images of before on the right hand at the top and after on the right hand at the bottom. We also can see that there are quite a few forces in the bay, and when some hard infrastructure was put up at the end of the 19th century in the 1870s, it was soon knocked down by the forces of the sea. And you can see why. If you look above that, at the top left hand side, you can see modern storms where there's grey infrastructure, hard walls facing the sea, large waves, very large waves. But if you see in the bottom left hand corner of that image where there's a beach, those waves are quite readily dissipated and they don't have the same sort of impact. So this demonstrates the benefit of nature-based solutions over hard grey infrastructure over the last 100 years or so. If we look at the charts from before and after the new harbour was built, we can see there have been some quite radical changes in the coastline. The beach is much reduced in size, and also there's been developments in Tolcarne. The Newlyn River has been squeezed, which is reflected by the art and images on the right hand side. There was once a nice floodplain there, which now has been built in and put a lot of pressure on the Coombe River as it enters the sea. The result of all these developments has been to focus energy towards the mouth of the Coombe River. And we are now looking for nature-based solutions to solve the problem. If the forces of nature had been taken into consideration before the grey infrastructure was put into place previously, we wouldn't be having these problems now. So what can we gain from historical evidence? Well, it can highlight recent changes along the coastline. It can demonstrate past periods of natural stability. It can show the impact of human development. Then we can use the data to calibrate long-term progressive change. We can use visual sources to demonstrate change to the public. And we can use information to inform on patterns of change to aid the development of nature-based solutions. And finally, we can gain wisdom from hindsight. Here, this should ensure that we don't make the same mistakes again.